Okay, so in this video, I'm going to define two words for you. I'm going to define vector and scalar. So I'm going to write in red vector, and in blue, I'm going to write scalar. Um, I'll start with scalar. A scalar has size. A vector, on the other hand, has size and direction. Okay, so um, if you've watched my video on distance and displacement, you're going to see some similarities between the difference of distance and displacement and the difference of vector and scalar, right? So a vector we can represent by an arrow, right? Because the arrow has size and it also points in a direction, right? I can draw different sized arrows and arrows pointing in different directions. These are all vectors and they're all different vectors, okay? A vector has size and direction, okay? Uh, Notice that if I draw, oops, trying to get this as, wow. All right, let's just start that over. If I draw two vectors like this, and let's even draw a third one so I can do it in a different color. I'll draw a yellow one right in between this. All three of these vectors are the same vector, right? They're all the same. Now, this is going to feel a little weird, right? Because you're going to look at me and say, no, they're not the same, right? There's a red vector and it's up there, and there's a yellow vector. It's a different color, Mr. McClure, and it's in the middle here. And well, there's this red vector here, and it's right below the yellow vector. So clearly, these are all not the same. Well, in some sense, you're right, uh, but in terms of vectors, they're the same because remember, what does a vector have? A vector has size and direction. It doesn't have color, right? It doesn't have position. It has size and direction, right? So a vector doesn't care where it's at. It doesn't care what color you drew it as. All it cares about are size and direction, okay? So, um, yeah, that might take a little bit to kind of wrap your brain around that. And if it's confusing, that's okay. That took me a really, really long time to grasp why these three vectors are the same, right? You can let that kind of sit in your brain all year or even into your next physics class, right? Um, if you don't quite understand it, don't worry too much. As long as you understand that the vector has size and direction, you're going to be okay. Um, Now coming back to our scalar, a scalar just has size, right? So um, I might represent a scalar as a line segment here, right? Scalar just has size. And I might not even, you know, do a line segment. I could actually really, the easiest representation of a scalar is just 1, 2, 5, 20 numbers, right? Now, to kind of illustrate uh, what I was saying about vectors and say it about scalars is I could have a purple 20 over here. I could have a green 20 over here, but these are all, these two 20s and this 20 over here are the same, right? They're all 20. You know, clearly I've drawn, three different 20s, but in terms of a scalar, right? Scalars only have size, so these are the same scalar because they're all the same size. So again, maybe a weird concept to wrap your brain around that all three of these are the same. But probably not so weird as trying to wrap your head around the fact that all three of these vectors are the same. So yeah, that's a vector and scalar for you.